Hello, everybody. Today we are talking about calculus, and hopefully, you watched my first video that would give you um, kind of an idea why you should learn about calculus, and I hope it got you excited because you've been learning about math most of your life now, and you might have been wondering why you're learning all this math and how is it applicable to real life, and hopefully that video got you excited. Unfortunately, we're not going to do any real life type problems today. Instead, we're going to talk about limits. And you might want to ask Mr. Nicholson, why are we going to talk about limits? And the answer is it's because all of calculus is based on this concept of limits. And hopefully that doesn't get you scared. I know calculus kind of has a bad rap of being a very complicated subject, and therefore maybe limits are also very complicated. And the good news is it's not. Limits are actually extremely simple. So I do not want you to overthink anything that's in this video. Okay. So what are we going to talk about specifically? Well, we are going to talk about what a limit is, and I'm not going to go in depth. I'm not going to rigorously define a limit. We're just going to kind of get you an idea of what a limit is, kind of loosely define it, and then once we know what it is, I'm gonna talk to you about how do you find out the limit. How do you find the limit? And I have three different ways you can do it. You can either evaluate, calculate, or through observation. So when you hear the word limit, kind of what comes to mind when you hear the word limit? Well, for me, when I hear the word limit, I think of a speed limit. So I kind of I have a car here, and speed limit is 55 miles an hour. And hopefully everybody knows what a speed limit is. And in case you don't, it's the limit. It's how fast that you are allowed to go. And in this case, I have 55. So you can go 55 miles an hour, but you can't go any faster than 55 miles an hour. Well, you could, but you're not supposed to. So is that what we mean in math? And it's not exactly what we mean. But before I kind of talk to you about what limits mean in math, I thought we would listen to a little Sammy Hagar and see what he has to say about going 55 miles an hour. All right, well, there you have it. Sammy Hagar says that he can't drive 55. And I think we know what Sammy means. He's saying that he can't drive any slower than 55. But what happens if somebody said that to you? I can't drive 55. Well, maybe it means exactly that. That the car can go, maybe slower than 55. Maybe the car can go faster than 55. But there's something wrong with the car. It just simply can't go 55 miles an hour. So you could try accelerating and getting closer and closer and closer, maybe super close to 55, but it just won't hit 55. In fact, at some point it might even go faster than 55. And then if you try to deaccelerate, see if you can kind of slow down into 55 again, you can't do it, and it kind of pops into 54 miles an hour. And that is what we're talking about here when we're talking about math limits. Okay, it's kind of like what is going on as we kind of approach a speed or approach a number. And how did this all thing start? Well, again, I can't drive 55. When in math, and think back for a moment, when were you told in math that you couldn't do something? And you have to think way back. Probably sometime around second and third grade. When were you told you couldn't do something? And hopefully you have an answer in your mind. And I will answer that in just a second, but let's go ahead and look at a function. Here I have the function f of x equals x squared minus 1 over x minus 1. Okay? And I went ahead and I factored the top. So I have x plus 1 times x minus 1 over x minus 1. And I drew and this is what the graph looks like of that. Well, close. There's actually something wrong with this graph. And hopefully you kind of can see where the problem is here. And that is, if I plugged a 1 in for x, then I would have 1 minus 1, and that would be a 0. And you can't divide by 0. And that was the answer to the question, that you cannot divide by 0. So to represent that on the graph, what I would have to do is I'd have to go over here at x equals 1, kind of up, and this, hopefully is a little bit of review for you, maybe not, but here we go, and, we kind of would, make a little circle here, and let me get in our color and see if I can erase a little bit. Okay, so there we go. So we have a break in our graph, and this shows here that, to satisfy this function, it can be any point along this line except for x equals 1. So, and that should be obvious to you, kind of looking at this thing. So when we're talking about a limit, again, going back to our car analogy, let's say we're kind of driving along this road here, or you can think of this as a speed, and we're getting closer and closer to 1. And as we get closer and closer to 1, we've got to ask ourselves, what is this function doing? Well, as we get closer to 1, the function is getting closer and closer to 2. F of x is getting closer and closer to 2. And again, over here, if I'm going down this way, you can kind of think about this as deaccelerating or just kind of traveling down the road from this direction. As I get closer and closer to 1, again, f of x is equal to 2. And I want you to notice that I looked at this thing from both sides, kind of going up this direction and coming down in this direction. And that's going to become important. I just want you to make note of that because it will become important in later videos. All right? So how do we say this in math? How do I say that? Well, and this goes to, math grammar here. Some more math grammar. And we would write this as the limit, Lim, the limit as x approaches, and this is an arrow pointing toward 1, as x approaches 1. And we would say, well, that equals 2. As x approaches 1, as we get closer and closer to 1, the function gets closer and closer to 2. F of x gets closer to 2. And you might think, well, that seems easy. And it is. And that's why I don't want you to overthink this. There's no catch to this. It is actually that easy. So let's go ahead and start talking about what I mean by evaluating. How would I evaluate a limit? And this is what a typical limit problem is going to look like. And this would say, this is how you would read it. It would say the limit as x approaches -3 of the function x squared minus 9 over x plus 3. And this is very similar to our previous problem here. And when you're trying to evaluate, the first thing you can try to do is simply plug in the value that this function, the number that the limit is approaching. What is x approaching? Well, it's approaching -3, so we'll plug it in for x. And if we do that, you should notice right away, well, I'd have a -3 plus 3 in the denominator, and that's a 0, and we can't do that. So what should I do? Well, just like I did in the previous example, is should try factoring. So if I factor the top, I'd have an x plus 3 times an x minus 3 all over x plus 3. And of course, I can go ahead and cross these two out because that would be a 1. And I'd be left with f of x is equal to x minus 3. And therefore, I can just plug in the -3, and I would have a -3 minus 3, and that would equal -6. So let's go to our graph and see if that makes sense by looking at it. Well, first thing I have to do is fix the graph, because since x can't equal -3, I have to come down here, and I got to put another point of discontinuity. And let me go ahead and kind of erase that line there. So put a little break in the graph at x minus 3. So there we go, kind of not perfect, but you get the idea. So, as I come down this way, I'm getting closer and closer to x equals -3. And what's going on with the function? Well, it's getting closer to -6. And again, kind of coming up this way. Again, the function is getting closer to -6. So we can feel pretty good that, yes, the limit as x approaches -3 would be -6. Let's talk about through observation. And we've already kind of done this in the previous examples. And here I have f of x equals x minus 2 over x minus 2. And we have, and the question is, what is the limit as x approaches 2? Well, if I tried evaluating this and I plugged 2 in for x, I'd have 2 minus 2, which is 0, and I have 2 minus 2, which is 0, and that's 0 over 0, which you can't have. So, but what I could do is I could simplify this function, because x minus 2 over x minus 2 is simply a 1. Is simply 1. So let me go ahead and I'll draw a line here. Draw a line at x equals 1. And there's our line. But of course, just like in the previous examples, there is a problem with this, and that is x cannot equal 2. So I'd need to come up at 2 here, and I'd have to put in a point of discontinuity again. So let me go ahead and do that. All right, so I got a hole at x equals 2. And so we can ask ourselves, by just observing this graph, what happens as we travel along this road, as we get closer and closer to x equals 2. From this side, what's the function doing? Well, it should seem pretty obvious. It's 1. It's approaching 1. And again, kind of coming around from this direction, from the right-hand side as I travel along here. Again, it's, x is equal to 1. So that's what we would write. We would write that x is equal to 1. And you're probably shaking your head a little bit saying, okay, Mr. Nicholson, this seems very simple, and I'm going to remind you again, do not overthink this. Let's look at another example. Here, we're getting a little bit more complicated, okay? I have a lot of stuff going on here, and I'm kind of showing you all the different ways that you could look at this limit. So this function reads, I have f of x is equal to x squared minus 9 over x plus 3. But it equals that only when x does not equal negative 3. And when x does equal negative 3, I'm saying that the function f of x is equal to negative 3. So you can get an idea what this function looks like. I already have it done. I have my point of discontinuity here at x equals negative 3. So the graph kind of goes up this way. And then when it hits negative 3, when x equals negative 3, f of x equals negative 3, so it goes up here. And then it continues on its way again. So what you may be tempted to do through observing this graph is you might go, well, okay, well, the limit then, as the function goes down this way, you might say, well, it's getting closer and closer to negative 6, but wait, it jumps up here. So is the limit negative 3, or is the limit negative 6? And I'm here to tell you that the limit is negative 6, just because that there is just a point that's floating around up in here in space. The question about the limit is, what is the function doing as you get closer and closer? And you can observe this. It's getting closer and closer to negative 6. You could ignore that point. Another way of thinking about it is, what would make this function, this line, continuous? And if I can just plug in a single point and make the entire function continuous, well, that's what the limit is. And of course, we could evaluate that. I could evaluate that just like in the previous example. It's the same problem. I could cross these off. I could take I could take negative 3, plug it in for x, and I would get negative 6. Another way of doing it, though, is you could calculate the limit. And the way you calculate the limit is you just plug in numbers that are getting closer and closer to negative 3. And I have it here, and as you can see here, I have from the right and from the left, and I'm looking at what this function is doing, and I can see that the function again is getting closer and closer to negative 6. So let's do some independent practice. What you should do right now is to see if you understand what I'm talking about, is pause the video and work these problems out. So go ahead and pause the video right now, work out these two problems, and then let's see if you get the right answer. Okay, so hopefully you paused the video and you're back. Let's see what you got for this one over here on the left. And as you can see, we were able to simply evaluate this limit by plugging in 3 for x. And it came out, and we're able to do so. Okay? And the answer was 2. Not too bad. But what about this one over here? Here we have the limit as x approaches 2. And you should notice right away when we plug 2 in for x down here, again I'm going to get 4 minus 4, which is 0, which I can't do. So following our strategy, we should probably try factoring first, which is what we do. We factor the top and the bottom. And as you can see, we can cross these two out. I'm left with 3x plus 5 on top and x plus 2 at the bottom. And then I can evaluate my limit. And I get 11 over 4. Hopefully you got those right. So what did we learn? Well, we learned that limits approach but never get to the number. And to find the limit of a function, we should first try and plug the number in to see if it is defined. If we are unable to plug the number in because it is undefined at the point, we could try factoring. And then you can also use your graphing calculator to see what the graph is doing and find the limit through observation. Plug it in, find the graph, and just see what is this graph doing as you approach the limit. And the last thing that we could always try to do is we could try calculating the limit by just plugging in numbers into the function on either side of the limit to see what the function is getting close to. Do some problems, and I'll see you in the next video.